So in this video, we are going to talk about how to properly comprehend or understand lag time. Now we've established that we could enter dependencies to establish a relationship between tasks in our project. But the dependencies are not enough to cater for some of the delays that we can possibly experience in our projects. So you remember the four dependencies that we mentioned: finish to start, start to start, finish to finish, and start to finish. Now let's imagine that we are building a house, right? And we need to erect walls only after our concrete has properly cured. So these two tasks will constitute a finish to start relationship. But we can't start erecting the walls until after 5 days. We need to leave out these 5 days because the concrete has to cure within those 5 days. Now, the problem is it wouldn't be wise for us to factor these 5 days as time taken for the concrete to cure in our project. Because if we say, for instance, that is going to take let's say 5 days to allow for the concrete to cure, basically what we are saying is that within that 5 days we are going to cost the project and we are going to allocate resources, because that is how Microsoft project is going to understand the 5 days. So within the 5 days, it will assume that there will be masons who are working there. It will assume that they are carpenters or whoever who are working there on and on. And that is actually the wrong idea, because within the 5 days, that is not what is happening. Rather, we are just allowing time to elapse. Okay, so for us to be able to establish that there is a delay between those two tasks, we use what we are calling a lag time. So we can actually represent lag times numerically. We can either do it as a direct duration value or as a percentage. So for an example, if you are waiting for the concrete to cure, it may take about 5 days. And we can write this as 5D in the tag field of the erect wall task. Now we are writing it in the erect walls task and not in the pour concrete task, because this is the task that lags behind the predecessor. So erect walls lags behind its predecessor, which is the pouring of the concrete. So we will rather add the 5D to the lag column of our task erect wall. Now another challenge is this. Project is going to assume these 5 days as actual 5 days, or if you want 5 working days. Now, and we don't want that, because the curing of the concrete can actually occur over the weekend or something of the sort. So what we could do in this scenario, instead of saying 5D, which is 5 days, we are rather going to use 5ED, if you remember from some of our previous videos. And ED represents 5 elapsed days. So that is what we would do. Instead of doing 5D, we are going to enter 5ED, which is 5 elapsed days. Now, just as was written, or just as was discussed above, we understood that we could enter the lag time either as a percentage or a direct duration value. Now, for the direct duration value, we are entering 5 ED, that is 5 elapsed days. But if you want to write it as a percentage, then the percentage will be calculated as a percentage of the predecessor task. So in this example, a lag of 80% has been entered in the lag field of the erect walls field. Now in that case, the percentage is calculated as a percentage of the predecessor task. So in this case, the time taken to cure will be calculated as a percentage of pour concrete and not a percentage of erect walls. So here is a background to lag time.